Welcome back, Honors Geometry students. Today we're going to take a look at probability with combinations. And again, we are hanging out and learning Target 4A, where we're going to be taking a look at events as subsets in the sample space to calculate probability. Alright, and specifically we're going to focus in on combinations, where the order of objects does not matter. Okay, and or the objects are replaced and combinations are formed. There is this handy dandy button on your calculator that is read as NCR. We would pronounce that as choose. Okay, and to find it on your calculator, my calculator's over on the right hand side. I'm going to tap on math, and then in the PRB function, I'm going to see it as option number 3. So if I want to take a look at example number 1, where I want to 6 choose 3, we're going to have 6 total items and want to choose 3 of them, and order doesn't matter. So let's say that you have a group of 6 friends and 3 of them are going to have ice cream. How many different ways can you make that group of people that have ice cream? It doesn't matter which order you give out that ice cream as long as 3 people have it. So order doesn't matter there. So on the calculator, you're going to type in 6, and then you're going to hit the math button, and then that PRB button to get into the probability menu, and then the NCR button for combinations, or we pronounce that as choose, and then we'll hit the 3 button. So I type in 6, get to math, PRB for probability, NCR for choose, 3, and I end up with 20. Take a moment, pause the video, and complete the rest, and we will compare. Okay, hopefully you had a chance right now to take a look. In this next one, notice that we have 2 items and we want to make a group of 7. If you only have 2 items, you can't make a group of 7. So anytime that first number is smaller, just like we did in permutations in our last video, we have 0. Okay, next one, because we can't make a group of 7. Next one, we have 5 items, we want to make a group of 5. There's only one way to do that. And last but not least, if we want to multiply together, 8 choose 3 times 10 choose 4, we end up with 11,760. Okay, and again, the difference between last lesson and this one is here order does not matter. Last time with permutations, order does matter. All right, example number 2. There is, in some states they have a lottery known as Little Lotto. I believe Illinois has this, and you are going to choose 3 numbers 0 through 9. So the way they do it, they have these 3 different buckets, and from each of those 3 buckets you can pick 3 different numbers, 3 numbers, 1 from each of the buckets. So in bucket number 1 there's 0 through 9, bucket number 2 0 through 9, and bucket number 3 0 through 9. So if we want to calculate the probability of winning Little Lotto, if we choose Quick Pick, meaning that the computer chooses for us. So in this first bucket, okay, if we want to calculate our total number of possibilities, we have 10 items and we want to choose 1. Okay. In that second bucket, we have 10 items. We are going to choose 1. Same thing with the last. Okay, and we end up 10 choose 1 times 10 choose 1 times 10 choose 1. We get 1,000. So the probability of winning this, there's going to be 1 combination out of 1,000 that would allow us to win. For your formative on Blackboard, when you are calculating the probability for the last question, you're going to be asked to enter that number in as a decimal, rounded to 2 places after the decimal. So I would type in 1 over 1,000. And for whatever reason, my calculator is set up to give me a fraction, so I can go to math and choose convert to decimal, item number 2, and it would give me 0.001. So I would round that to the nearest, I believe I said hundredth, so in that case it would be 0.00 that you would type into Blackboard, which is kind of silly. You won't have to worry about that situation there. All right. You could have also done this in a faster way. This one you didn't necessarily have to use combination. In fact, first bucket has 10 choices, second bucket has 10 choices, third bucket has 10 choices, and it's still 1,000 choices, and you don't necessarily have to think about it using combination. Okay, example number 3, it says Beth and Shayna each purchased 1 raffle ticket. If a total of 11 raffle tickets are sold and 2 winners will be selected, what's the probability that both Beth and Shayna will win? Well, in that case, it doesn't matter if they announce Beth first and then Shayna, or then Shayna, then Beth. As long as they win, so order doesn't matter. Okay, well, I notice here that we have 11 raffle tickets, and we want to select 2 winners. Order doesn't matter, so we're going to choose 11, choose 2. And when we type that into the calculator, we end up with 55 different possibilities for selecting both Beth and Shayna. If we want to calculate the probability, that's the likelihood that this is going to happen, there is one way to choose 2 winners. Okay, Beth and Shayna, Shayna and Beth, that's the same combination. There are 55 total possibilities, and like I said, in Blackboard, you are going to type this in as a decimal, rounded to 2 places. So on Blackboard, this is 0.181, so to 2 places after the decimal, I would round that to about 0.18. Okay, last but not least, example number 4, there's a couple questions pertaining to this in your homework. Usually we talk more about it in class, so I just added another one in here. It says, how many ways can you pick exactly 1 ace when you choose 2 cards out of a deck? Alright, so some things to keep in mind. If you're dealing with a deck of cards, there are 52 cards. Okay, this card, for this particular question, it doesn't matter, but if you're talking about the suits, there are 4 suits. There are hearts and diamonds. Okay, let me color code here. Hearts and diamonds. Those are both red. And then we also have spades and clubs hanging out in there. Okay, and those are black. Okay, and then as far as the value goes for the cards, we have 2s, 3s, 4s, 5s, 6s, 7s, 8s, 9s, 10s. We have jacks, queens, kings, and aces. And for all of those, there are 4 of each of those, one corresponding to each of the suits. All right, so that little bit of background information is going to help you out solving some card questions. All right, but getting back to our specific example, it says, how many ways can you pick exactly 1 ace when you choose 2 cards out of a deck? All right, so if we want exactly 1 ace, okay, so like I said before, when we're talking about our values, we're talking about aces. There are 4 different aces, and we are going to try to choose exactly 1. Okay. So there are 4 choose 1 ways to choose 1 ace out of that deck. But it says we want to choose 2 cards out of the deck. And let's assume that we're not putting the card back into the deck. We are taking both of those out at the same time. Alright, so in that case, we got to keep in mind that, hey, there were 52 cards in that deck, but we just took out 1 ace. There are 51 cards left. So 51, and I want to choose, I need a total of 2 cards. I already picked 1, so I need to pick 1 more. And there we go. So if I want to figure out the number of possibilities, okay, notice that we're not doing probability, we're just doing number of possibilities. I would do 4 choose 1 times 51 choose 1, not 19, choose 1. And I would have 204 total possibilities to choose exactly 1 ace when I choose 2 cards out of a deck of cards. All right. The rest of, once you're finished here, you're going to take a look at the combinations worksheet, either in Notability or on Class Kick. And then there's a 4-question formative. You have 3 attempts to that hanging out on Blackboard. Please reach out if you have any questions. I'm here to help. Talk to you later.